Hi guys, it's North State forecaster Sarah McCoy, and something magical and magnetic is unfolding in our skies next weekend. Here in Northern California, we are no strangers to the aurora borealis, but this year's lights will likely be more visible and powerful due to the sun reaching the peak of its 11-year solar cycle, known as the solar maximum. So on May 30th, the sun released a coronal mass ejection, or CME, a huge cloud of charged particles, mostly electrons and protons, blasted out from the sun's corona during a solar flare. These particles travel through space at millions of miles per hour and are expected to hit Earth this weekend. When those particles reach Earth, they slam into our magnetosphere, our planet's invisible shield. The collision causes gases in our upper atmosphere like oxygen and nitrogen to be disturbed, causing the waves of green, pink, and purple lights. The green, sometimes the easiest to see, comes from oxygen 60 miles up. The red is even higher at 200 miles up, and purple and blue is the nitrogen. So how well will we be able to see the skies this weekend? Right now, it's looking like we'll have some slight cloud cover going into Friday night, but Saturday is likely going to be your best chance to have some clear skies and be able to see that aurora borealis. If anything changes, we'll keep you updated online and in shows. But if you get any photos of this weekend, please make sure to chime them in because I would love to see them. Hi guys, it's North State forecaster Sarah McCoy, and this video is for all of the weather lovers who like to dive a little bit deeper into severe weather and what causes them. So today we're going to be talking about hook echoes and how to identify one. So notice that this larger system right here has been creating a lot of moisture for Washington and Oregon, and only for the North State. It's brought a little bit of moisture, but it's also brought much lower temperatures because it's a trough of low pressure as well as some easterly wind gusts. But we haven't talked about how it's affecting the Midwest out there. So it's actually the driving force behind some of the severe thunderstorms that they've been seeing out of North Dakota heading into Minnesota. But what's interesting about this severe thunderstorm is right before one of the final frames, it develops a well-identifiable hook echo that you can see start to wrap around. So the hook echo is usually driven by sometimes hail, mainly heavy winds, but often debris as well. And that's kind of how you can identify between a severe thunderstorm and a severe thunderstorm that is likely producing tornadoes. So I wanted to take a closer in look to that so you guys can see how well developed that is. It's just textbook 101. You can easily identify that. So I wanted to show a good example of a hook echo while we had one on our radar right behind us. So that's how you know how to identify the hook echo moving forward. So you guys can take a look at that, but just stay safe out there with these severe thunderstorms. And it did drop down now to a severe thunderstorm warning, but we do have lots of tornado warnings coming with this system because of that hook echo is likely a tornado producing cell. Hi guys, it's North State forecaster Sarah McCoy, and I couldn't help but pop on and talk about squall lines today due to what's developing behind me. We've been watching this squall line develop, and now we have two very serious threats spreading across hundreds of miles. So these squall lines are long, narrow bands of thunderstorms that form along or ahead of a cold front. And now it's driven usually by fast-moving air masses and sharp temperature gradients. These storms are tightly packed and often extend for hundreds of miles, like you're seeing here. So here's how it works. Cold air rushes out ahead of the storm. We call that a gust front. That cold air lifts warm, moist air ahead of it, triggering rapid updrafts. As air rises, it cools and condenses, creating towering cumulonimbus clouds. The cycle feeds itself and moves fast, sometimes 50 to 70 miles per hour. They bring strong, straight-line winds, intense lightning, torrential rain, and sometimes even hail or tornadoes. You'll notice a tornado warning right there, but it's the winds that usually cause the most damage. The winds can be just as damaging as tornadoes. These winds are pushed out by strong downdrafts, slamming the ground, spreading out. So while it's just one line of storms, it's powered by serious atmospheric energy. This squall line is extra interesting because typically they develop at night when the jet stream is stronger and the cooler temperatures aid in stability. But squall lines are fast, fierce, and no joke. So follow for more behind the scenes science on extreme weather. Hi guys, it's North State forecaster Sarah McCoy, and after a blustering day that we had today, we also have some isolated thunderstorms in our forecast for tomorrow evening. So I thought it would be the perfect weekend to talk about microbursts. So if you've ever seen patio furniture knocked over or trees knocked over due to a sudden gust of powerful air, that's likely a microburst. So it's a powerful downdraft from air from a thunderstorm that slams into the ground and spreads out in all directions with wind speeds up to 100 miles per hour. There are two types of microbursts. There's a wet microburst, which is caused by the interaction of falling precipitation with dry air near the surface and the subsequent cooling of the air. And then the second type, which is going to be what we're mainly covering today, is going to be a dry microburst, which is caused by dry air enrainment and evaporation cooling. This means that dry air aloft can enter a developing thunderstorm that can contain rain and hail and evaporation, which causes a lot of cooling, which you guys know that since the cool air parcel is going to enter that area, it means that it's denser and it's going to be released and dropped lower to the ground. So it gets released into a rapid fire motion. And it's going to look somewhat like this here. So this is going to be a much slower version of the release of that cool air drainage. So you can see it right here. It's taking a little bit of a while to click through, but this is a much slower version of what you might see that would happen much faster in the atmosphere. So you can see that's going to be what it looks like from this perspective, but you can also see it on a radar. So when the air makes its way to the ground and starts to spread out in all different directions, you can see little patches of mostly green and red. So it would look somewhat like this. So the green is heading towards the radar, and then the red is heading away from the radar. So when you see little patches like this, that means that there's certainly a microburst on the radar. So if you've ever seen anything like this in real life, please send a photo or a video to the comments and let us know. Hi guys, it's North State forecaster Sarah McCoy, and we have been doing a couple weather tutorial videos previously over the past couple of weekends, and this weekend we're going to dive a little bit deeper into some synoptic meteorology because it's actually very relevant to our current weather pattern. Here's our high and low pressure all across the United States, you'll notice, but actually this is how we're going to be looking at Monday evening. So this looks like two spin-offs of low pressure, but it's actually making the W, and if you're familiar with any sort of algebra or synoptic, you'll know that this is an omega blocking pattern. So what happens is it resembles the Greek letter omega, or in algebra, the lowercase w omega. So take a look at this pattern right here, and you'll notice that it kind of follows the same pattern right here. So this is why we call it the omega blocking pattern, but it has to do with the jet stream when we place it over a high and low pressure map. So you guys are probably familiar with the jet stream, the polar jet stream, and of course the subtropical jet stream also, but here's what our high and low pressure map is going to look like with the omega blocking on it, which is going to be coming to the North State and affecting all across the United States already Wednesday evening, and is affecting us a little bit right now. So here's what's happening. In the middle, we have a high pressure ridge. This brings warm, dry, and often sunny weather. On both sides, low pressure troughs bring cooler, cloudier, and wetter conditions. The jet stream loops around these systems, creating that omega shape. So that's what we're going to be looking at right here. And here's the high and low pressure map as well. So this pattern is called a block because it literally blocks the weather systems from moving. The high pressure stalls in place, and so does the weather. That can mean days of heat and drought in one area and days of rain and storms in another. So if your weather isn't changing, much changes in the area can be blocked by the omega, and here's why. So you'll notice this right now. So we have had some pretty nice warm weather previously, and a lot of it hasn't changed. And moving forward, we're actually going to get a little bit warmer. And here's why. We're going to be affected by this moving forward. So what does this mean for the North State? It means that we've been dry previously. Now that we have that omega blocking pattern all across the United States, that we're going to stay quite dry, and we're not looking at a lot of clouds moving forward. So we are going to be around the 80s to 90s, and I'll have that 7-day coming up tonight in our shows.